All right, so we're trying to do the matrices component of transformation. We had a first class. It didn't go so well. There was internet issues, but we managed to do a partial video and send it out. All right, the entire class was largely centered around two particular matrix. This one is the I matrix. So the I matrix is 1, 0, 0, 1. So that's the I matrix. So yeah. So that's one. And what we said is that when we apply the I matrix to the coordinates of a point, it does nothing to the point. So if I apply this matrix, let us say to the matrix AB.
But
yeah, as I was saying, if I, let us say, apply this matrix to a coordinate A, I'm going to get back A. It's not going to do anything to it. Now, the other matrix was the interchange matrix. All right, but back to the I matrix for a bit. 1, 0, 0, 1. So we said that the I matrix does nothing to, it doesn't do anything to a coordinate. However, if I put a 1 up here at the top there, if I put a 1 up there, what that 1 is going to do is it is going to change the sign of the x coordinate. Sorry, if I put a negative at that top 1, it is going to change the sign of the x coordinate. If I put a negative at the bottom, what this matrix is going to do is this matrix now, as you see it here, this matrix would change the coordinates of the, it would change the sign of the y coordinate. All right, so the next matrix we looked at was the interchange matrix. 0, 1, 1, 0. And what we said, what the interchange matrix does is that it interchanges the x and y coordinate. X becomes y and y becomes x. Again, if I put a negative at the one at the top, if I put a negative at the 1 at the top, what it's going to do is it is going to if I put a negative at the top, what this matrix will do is that it will interchange the x and y coordinate, and it will also change the sign of the x coordinate. All right, so the matrix as you see it now, it would interchange the x and y coordinate, and it would also change the sign of the x coordinate. Now, if I put a negative at the 1 at the bottom, what this matrix will do is that this matrix will interchange the x and y coordinate, and it would change the sign of the new y coordinate. All right, so that's what we have looked at so far. we talked about it, which y coordinate changes. All right, so what we want to do is we want to be able to write the matrix associated with this. We want to be able to write the matrix associated with this transformation. So I'm going to start out with the I matrix. 1, 0, 0, 1. Now, the I matrix does nothing to a point. But if I put a -1 here, what this matrix will do, the matrix that you're seeing, 1, 0, 0, -1, this matrix will change the sign of the y coordinate. That's all it does. Therefore, this is the 2 by 2 matrix that is associated with reflection in the x-axis. What this matrix does is that this matrix will change the sign of the y coordinate. Now, the same thing happens when you reflect a point in the x-axis. Therefore, this is the 2 by 2 matrix that is associated with reflection in the x-axis. Number two says, the image of any point xy under reflection in the y-axis is -xy. The sign of the x-coordinate changes while the sign of the y-coordinate remains the same. So again, I'm going to start out with the, I'm writing the 2 by 2 matrix that is associated with this transformation. I'm starting out with the identity matrix. The identity matrix does nothing to a point. It doesn't do anything. All right. Remember, this is the interchange matrix. All it does, it interchanges the x and y coordinates. But if I put a negative there and a negative here, it will both interchange the x and y coordinates, plus it will also change the signs of the x and y coordinates. These are the matrices which are associated with the different types of reflection. What we need to be able to do is that we need to be able to remember them, or if we can't remember them, we need to be able to derive them. All right? All right, let's go on to the next page. All right, this says example 3. Example 3 says, draw triangle P prime, Q prime, R prime, the image of triangle PQR under a reflection in the x-axis. All right, so I'm doing this example, or we are doing this example together. So, all right, so we don't reach the matrix part of it yet. All we're being asked is to draw the image of PQR under a reflection in the x-axis. So R, which is here, is going to come here. So this is R prime. Because in a reflection, the object and the image are the same distance from the mirror line on either sides of the mirror line. You will also notice that P, the mirror line, is the x-axis. So the mirror line, this is my mirror line. The mirror line is the x-axis. Now, P is what? Is 3 units above the mirror line. So P prime is going to be 3 units below the mirror line, but on the other side. So this is 1, 2, 3. P prime is going to be here. Everybody should remember, And if you don't, let me remind you, in a reflection, a point that is on the mirror line is invariant. It means that that point does not move. You'll notice that Q is on the mirror line. So in a reflection, Q will not move. So Q is both an object and an image point because it is on the mirror line. So obviously when we finish, we're going to what? All right, we will just connect the points using a ruler. All right, so we have done the I part of the question. And the I part of the question is asking us to draw triangle P prime, Q, R prime, the image of triangle PQR. So this point is both Q and Q prime. All right, the image of triangle PQR under a reflection in the x-axis. Next, we're asked to state the coordinates of P prime, Q prime, and R prime. So let's do that. P prime. Q prime, R prime. All right, can somebody help me with the coordinates, please? P prime, Q prime, R prime. Can somebody help me with the coordinates, please? Anybody?
And so, sir, P prime would be 1 minus 4.
No, go again.
1 minus 3, sir.
1 minus 3. Now, if you notice, it's a P was 1, 3. Now, P prime is just what? 1 minus 3. The only thing that happened is that the sign of the X of the Y coordinate changed. Q prime is still 0, 4. Can somebody give me the coordinates of R prime? Somebody give me the coordinates of R prime, please.
Minus 1, 1.
Sir, minus 1 to 1.
So it's minus 1, 1. Please notice, R is the point minus 1, minus 1. But R prime is the point minus 1, 1. The only thing that happens when you reflect a point in the what? X-axis is that the sign of the Y coordinate changes. All right? Now, the third thing we're asked to do, we're asked to state the coordinates of the vertices of P, Q, and R. All right, well, let us do that quickly. P, Q, and R. P is 1, 3. Q is 4, 0. It wasn't 0, 4, so I was wrong. Which somebody should have pointed out to me.
And then
So this is 4, 0. And lastly, R is the point minus 1, minus 1. And if you do a comparison between P prime, Q prime, R prime, and PQR, you will see that the difference between the points on the objects and the points on the image is that the sign of the Y coordinate change. All right.
excuse me, sir. Sir,
Yes.
R prime is negative 1 to negative 1. And a positive 1 to negative 1.
No, R
It's a
prime is
R
negative
prime.
1. R prime is negative 1, 1. Negative 1 vertical and positive 1 horizontal. That's R prime. R prime which is above the x-axis, is -1, +1. -1x, this is -1x, and +1y, horizontal. All right. The next thing, so we have done 3. Next, we're asked to state the 2 by 2 matrix associated with reflection in the x-axis. Well, we can easily write that somewhere. We didn't leave much space for it, but we could write it in. No, let's just write it down here. M X is the matrix 1, 0, 0, -1. This matrix does the same thing as a reflection in the x-axis. It changes, it keeps the x-coordinate the same, but changes the sign of the y-coordinate. Therefore, that is the 2 by 2 matrix that is associated with reflection in the x-axis. Next, we're asked to show that the coordinates of the vertices of P prime, Q prime, R prime are those. We're asked to show that. What we're going to do is, I'm going to show you how you could use calculation to determine the coordinates of P prime, Q prime, R prime. Now, first of all, P is the point what? 1, 3. P, 1, 3. Q is 4, 0. R is -1, -1. I'm going to apply this matrix to it, 1, 0, 0, -1. This matrix is MX. What I should end up with are the coordinates of what? P prime, Q prime, and R prime. So we're going to multiply what? The number of columns in the first matrix must be equal to the rows in the second matrix. We need to switch this around. Whenever you're multiplying 2 matrices, the number of columns in the first matrix must be equal to the number of rows in the second matrix. So I've got to switch these around. We're going a little bit slow, but let's follow. 1, 0, 0, -1. Remember, 2 matrices are compatible. So this is P, which is P is 1, 3. Q is Q is 4, 0, and R is -1, -1. Let's multiply row by column. So it's 1 times 1, 1, 1, and then what? 0 times 3 is 0. I'm going to multiply the top row by all of the, so this is P prime, Q prime, R prime. 1 times 4 is 4. 0 times 0 is 0. I'm multiplying the top row by all of the columns. Then the top row by the right column, 1 times -1 is -1, and 0 times -1 is 0. Next, I'm going to multiply the bottom row by all of the columns. So bottom row, left column, 0 times 1 is 0, -1 times 3 is -3. Bottom row by the middle column, 0 times 4 is 0, and -1 times 0 is 0. Bottom row now, right column, 0 times -1 is 0, and -1 times -1 is +1. A negative times a negative is a positive. So this would make this matrix 1, -3, 4, 0, and minus 1, 1. So this means that the coordinates of P prime would be 1, minus 3. The coordinates of Q prime would be 4, 0. It is unchanged because it is on the mirror line. And the coordinates of R prime would be minus 1, 1. So this is how calculation may be used to determine the coordinates of the image of a point under a inner reflection. All right, please note it, everybody.